So, just as a review, we've been talking about slope. What is slope? Slope is the rise over run. The change in y over change in x. y2 minus y1 over x2 minus x1. What does slope look like on a graph? Like, how do we explain the slope to someone? How steep the line is, how tilted the line is. If I have positive slope, then from left to right, the line's going up. If I have negative slope, then from left to right, the line's going down. Okay, so there's slope. Then we started talking about different forms of an equation that have an x and a y. So what is slope, or what is, I'm sorry, what's one of those forms of an equation of a line? Slope, intercept form, and point slope form. When do we like using slope intercept form? When you know the slope and the y-intercept. Slope and intercept. Slope intercept form. When do we like to use point slope form? A point and the slope. Point slope form. Does anyone remember what slope intercept form looks like? What do those values represent?
Y is y, x is x, m is the slope, and b is the y-intercept.
So the m is the slope and the b is the y-intercept. And the x and y are any x and y that's on that line. And what does point slope form look like?
Y minus y1 equals m
times x minus x.
Yeah. X minus x.
Some things we need to notice. There are built-in negatives in the formula, which means whatever the number it is you see, it's the opposite sign that goes there. Right? Because there's built-in negatives for x and y. What do these represent?
Y1 is the y of 1 point, and x1 is the x of that same point.
So the x1, y1 represents the point that we know,
And m is the slope.
and the m value is the slope. Okay, so what we have today is we have a new form of an equation of a line. It's probably the least useful as far as graphing goes, but it's called standard form. Does anyone know what the standard form of a linear equation looks like?
If you showed me, I would know.
Okay.
I'm pretty sure we did this like 900 times. In the eighth grade. It's what? Yeah.
AX plus BY equals C, where A, B, and C are integers. So, standard form is like I said, probably the least useful for graphing, but it may be the most useful for word problems when you're given like criteria and constraints that you're having to try to build a situation around. Standard form can sometimes be very useful there. So again, A, B, and C are just numbers. None of them really mean anything. Like as far as slope or y-intercept, you can't think of it that way. But the big thing about standard form, it's the only form where x and y are on the same side. But if you think about slope-intercept form, y equals mx plus b. And point slope form was y minus y1 equals m times x minus x1. So here x and y are on the same side. That's how I kind of know I'm in standard form. So here we're going to give a situation, a word problem, and then we want to write an equation of a line in this situation. So Hannah's going to spend $150 on her music festival tickets. Reserved seats cost $25. General admission tickets cost $10. And how could we represent the situation with a linear equation? So if I'm going to write a linear equation here, look back at this, figure out what are the things that you don't know. So how many unknowns are there?
How many people go?
Okay,
How many tickets you want?
okay,
Which ticket she wants?
okay.
If she wants to get reserved seats in general.
Yeah, you're kind of all on the same idea. Like, in our heads, we could kind of figure out, like, what's something that Hannah could do with $150?
A lot.
By 15.
She could buy 15 general admission tickets and no reserve tickets. That's one option. What else could she do?
6 reserved seats.
6 reserved seats and no general admission tickets. So thinking about it that way, I have found what it is I'm able to identify here. How many of each kind of ticket is she buying? That's the real question. So we're going to let X represent the number of reserved tickets. And we're going to let Y be equal to the number of general admission tickets. So can anybody think of an equation we could write using x and y? And I'm going to give you a hint. X and y are going to be on the same side.
Oh, it's gonna be standard form.
It is going to be in standard form.
25x plus 10y equals 150.
So let's try to make sense of this in terms of the context of the problem. You're saying X represents the number of reserved tickets. So if I know how many reserved tickets she buys, and I multiply that by 25. So say I know she bought 4 reserved tickets. 4 times 25 means she spent $100 there. So if she bought 4 reserved tickets, then she would need 5 general admission tickets. 5 times 10 is 50. So that would be 100 plus 50 is 150. That's right on the money. That's exactly the equation we could write in general form. Notice how it has an A times an X plus B times a Y equals that C. And so, again, as far as on a graph, where do these points go? Don't think of it that way. Standard form is terrible for graphing. Don't think of the numbers as meaning anything on the graph. But they're really good at taking a word problem and putting it in a linear equation. That's their best use for standard form. Questions about what we did there?
What is 2 equals
3x plus 2 equals 12. 12 y?
No, 2 wrong.
Oh.
You know what I meant.
So what does x represent in your problem?
Then grapes.
X means green grapes.
You said why?
Cost of green grapes.
Yeah, so I would want you to be a little more specific than green grapes. Okay? X here represents the weight of green grapes that she buys. Or you could say the number of pounds of green grapes she buys. We know the cost. We know the cost per pound. So what I can do is, if I can take how much weight she has times the cost per pound, this is the cost of the green grapes total, is this whole term.
How come they're different? Like, how come's the green grapes one? Because
If it's not pizza or chicken, I'm probably not eating it, so don't ask me, I have no idea. No idea.
you don't like green dates?
Why is the weight of the red grapes? So here, we're going to graph it. What's the graph of 3x minus 2y equals 9?
Good question.
Have I told you it's
So
not great for graphing? Not great for graphing.
I
But I'm going to show you how you can graph with it, but that's not its best strength.
So X3, Y2,
No.
X3,
yeah, and then do you
No.
start at track 3?
No.
I wish it was that simple.
So that's one thing you could do. You could put it in slope-intercept form and then graph from there. Right? That's always an option. I could make it look like y equals mx plus b and then graph it. But I don't want to do that this time. That is an option, but I don't want to do it this time. I'm going to show you a different way that you can graph that sometimes might be somewhat useful, but it's not always. What do I need in order to graph a line? Like what?
I need a point and a slope.
I either need a point and the slope, or I need 2 points.
Oh.
Coordinates, 2 points, 2 coordinates. If I know 2 points that are on my line, I can connect them and make the line. Because what do we use the slope for, if you think about it? I find a point, I use the slope to find another point, another line. I need 2 points to make a line. So I'm going to show you how you can get 2 points from standard form. We're going to find the 2 intercepts. We're going to find the x-intercept and the y-intercept. So I want you to think here for a second. I know the x-intercept must happen somewhere on the x-axis. No matter where it happens, what do you know about the point? It's going to be on the line. I'm looking for one specific thing in general. So tell me everything you know about the x-intercept.
It's going to cross X.
It's going to cross the x-axis. Okay, I'll try to give you a little push. If the x-intercept is here, it is positive. What's its coordinates if it's there? It's 3, 0. Yeah, what if the x-intercept was here?
So it's always going to be 0.
What's going to always be 0?
Why?
So
X.
on the x-intercept, the y value is always 0. Right? This is 1, 0. This one is 2, 0, 3, 0, 4, 0, 5, 0, negative 2, 0, negative 5, 0. I don't know exactly where the x-intercept is yet, but I know the y value has to be 0 there. That's what makes it an x-intercept. Every x-intercept has a y value of 0. So guess what I can do? If I want to find the x-intercept, what do I know about the y-intercept? It must be, if I want to find the x-intercept, the y value must be 0. So I can plug in 0 for y. This goes away. 3x equals 9. So x equals 3. So I know the x-intercept is at 3. So there's a point. But in order to graph a line, I need 2 points. So the other point I'm going to graph is going to be the y-intercept.
Yes. And
What do I know about every y-intercept?
the X is 0.
The x value is 0. You answered that one a little quicker.
We already have to do this.
Have we?
This will become academy.
You had to graph by intercepts?
It was just like this.
Yeah.
You had to replace the X
I didn't get that far.
with the number and then work it out and then do it again with the Y.
Oh, yeah.
We did
If you say so. So I'm finding the y-intercept and the x value is 0. So I plug in 0 for x. This term is gone. So negative 2y. Remember, the sign in front of the number goes with it. Can I say that enough times this year? The sign in front of the number goes with that value. So it's a negative 2y. Divide by negative 2. So y equals negative 4.5. Through 2 points, there exists one line. There's the line. So when it's in standard form, this is the way we typically graph it. We could find the intercepts to graph. Now, some of you guys were saying we could put it in slope-intercept form. That is an option. Let's do that very quickly, just to see what that would look like. So to be in slope-intercept form, we need y by itself. So if I want to get this by itself, how can I do that?
Put a 0 for x. We don't.
You guys know how to isolate a term?
Yeah.
Subtract 3x.
So first I need to subtract 3x from both sides. So this goes to 0. I'm left with negative 2y equals 9 minus 3x. But to be in slope-intercept form, I need to reverse these two. Okay, but y is still not by itself because it's multiplied by negative 2. So I can divide everything by negative 2. So y equals positive 3 over 2x minus, that's 4.5. So now I'm in slope-intercept form. So the y-intercept is at negative 4.5. And the slope is 3 over 2. Which means I could go up 3, right 2. Up 3, right 2. Guess what? It's the same line. Right? No matter which way you graph it, you still point to the same line. Because it's the same equation. So you could do it this way too. If you're really comfortable doing slope-intercept form and you hate graphing by intercepts, you can swap between them. Just find one that you want to do. Every time? And a lot of people do make you do this every time. I'm not. Graph the line, graph the line. That's all it's about. You need to know this. You need to know this form, and you need to know the process because we're going to have to eventually get variables by themselves. If it just tells me to graph, however it takes to get there. Okay. Here's our question, still in standard form. What does the graph of ax plus by equals c look like if a is 0? So just think, if you plugged in 0 for a, then what happens to this term? It is gone. And so I'm just left with, this time it's 2y equals 6. So, okay, 2y equals 6. Well, let's go ahead and get y by itself.
If y equals 3, that means it would go like horizontally, right?
So I need to graph the line where y is always 3. Right, there's no x, there's no variation.
Exactly, because there's x is
So right here's a y-intercept of 3.
Horizontal line.
And then this is the point 1, 3, and here's 2, 3, and 3, 3, and 4, 3, and 5, 3. All of those points have a y of 3. So this horizontal line is the collection of all points that have a y value of 3. So when the a value is 0, you get a horizontal line. This one says, what does the graph of ax plus by equals c look like if b was equal to 0? So they give me the equation. They tell me to graph 3x equals negative 6. Well, same thing, we can solve for x. So x equals negative 2.
You go a negative 2 over x and draw 1, then
So here, this is the point negative 2, 0. Here's the point negative 2, 1, negative 2, 2, negative 2, negative 1, negative 2, negative 2. All of these points have an x value at negative 2. So that's the line x equals negative 2. Is that nonlinear?
That is non-linear.
It's not. It's still a line. It's a line,
Wait, it is non-linear.
but it's not a function.
Yeah, I got those backwards.
It's not a function. 'Cause it doesn't pass the vertical line test. The input of negative 2 gives a bunch of outputs. Every input can have exactly one, but this one has a bunch of outputs.